Use the graph to identify the roots and their multiplicities. Remember, another word for root is x-intercept. So I've asked you to circle where you see x-intercepts. All right, so at this position, which is -3, does the graph bounce off the x-axis or cut through? It bounces off, so that means it's an even multiplicity. Write the ordered pair -3, 0. At x equals 0, as an x-intercept, does it bounce off or cut through? So that means it's odd, 0, 0. Okay, go to go to the x-intercept of 4. Now this one often tricks students because it looks slightly different. But in the end, does it bounce off here or does it cut through the x-axis? It cuts through. It comes from the bottom, goes to the top, which makes it odd, so 4, 0. Hands up or hands down if you understood the concepts there. Okay, does anybody have questions? Flip to the back and find problem number 5. It should be problem number 5. Let's change the numbers here. Can we change this to a 5 and change this to a 6, please? Increasing or decreasing. Remember, you have to do this in terms of x values, and we're going to use parentheses. X values, and we're going to use parentheses, okay? So, state the intervals in which the function increases or decreases or remains constant. So, from left to right, what's happening right now? Remember, this is coming from the left while it's going down. This is going right and going down. So, it increases from negative infinity because it's coming from the left, and it continues to increase until it gets to an x value of -8. From -8 to -6, it is decreasing. -8 to -6, it is decreasing. From -6 up until an x value of 0, it is increasing. And from 0, and this is where most students get this wrong. Most students say, okay, it's going to decrease from 0 to, and they say negative infinity because they see it going down. Remember, this is in terms of x values, and it's going to the right. Going to the right with no limit is actually positive infinity. So I have those two done. The next part, where are the intervals where the y value of this function is positive? Okay. So I can see it's positive everywhere above and it's negative everywhere below. So from -10, now watch this. This is where this is a little confusing. This first shape that goes up and then back to -6 is going to be positive. So -10 to -6. And some students say, well, why can't I just do this entire interval? Because when you're at -6, you're actually on the x-intercept. You're actually on the x-axis. And when you're on the x-axis, we don't consider that positive or negative, it's neutral. So at -10, you're neutral. That's why we have a parenthesis. At -6, you're neutral. Parenthesis. Everything in between is positive. Then from -6 to +6, again, is positive, but at the location of -6 and +6, it is neutral. Okay, in terms of x values, remember we're doing this. Where is it negative? Well, it comes from negative infinity, and it stays negative until it gets to -10, and then it becomes neutral. So this is all negative. It comes from negative infinity. It continues being y values that are negative until it gets to the point of being -10. It also is negative over here, so it starts being negative at an x value after it passes an x value of 6, and it continues to go to the right, staying negative. All right, now we're going to talk about things called local and absolute maximum and mins. Absolute means the highest maximum point or the lowest maximum point. Sometimes you have more than one high point. The highest point is called the absolute. Makes sense, absolute highest. The local means it's still a high point, it's just not the highest. So let's circle these right now. These are both high points, hopefully you agree, right? Okay, So let's go and look at we're going to do maximum. So I'm going to worry only right now about local maximum and absolute. And we write them as an ordered pair. Which one ends up going higher? This one does, right? So as an ordered pair, that's your absolute. So we're going to say 0, 8. And the local is going to be negative 8, 6. Now, minimums. This is not a minimum value, sometimes a misconception of students, because it continues to go down and down. There's no end to it. Is there any point that's kind of like a valley? So this isn't a valley because it just continues to go down. This is a high point, like top of a hill. What about this point? Here's your valley. Is there any other valleys? Okay, so we just have one absolute minimum, and that occurs at negative 6, 0. There's not more than one, so I'm just going to put NA for local. End behavior. As we go to the far left, it's going to the left, but it's also headed down. As we go to the far right, it's headed right, but it is also headed down. Okay, so let's go back to our x-intercepts. At negative 10, there's an x-intercept. Would you consider this odd or even at negative 10? It's odd. Why do we say it's odd? Because it cuts through. So find odd, and let's write down the ordered pair negative 10, 0. Go to negative 6, 0. Negative 6, 0. This one bounces off, so we considered it even. Find even multiplicity roots, and we are going to write down negative 6, 0. This is only for x-intercepts. And at positive 6, it cuts through, so we say it is even or odd. You guys tell me. Odd. 6, 0.